Thursday night build. Oh, give me a second. I gotta update the name of the the stream. So Thursday night builds. Tonight we're doing the Stream Deck Part 2. Last time we managed to get all of the hardware part of it working. So from that, we've managed to figure out one side of this problem. The other side of the problem is, of course, software. So just one moment. This is going to be makers and crafting. I always forget what it is. I'm going to make it cooperative. Cooperative creative RL. Update. There we go. I'm not playing block game. I'm not playing Stream Elements. I'm not. Okay, hopefully it's updated now. It's Thursday Night Built Stream Deck Part 2. Let's just double check that we're actually on Twitch here. And that's what it says. Refresh it. There you go. I actually should be hacking a Stream Deck. Part 2. Should we also say software?
Yeah.
Development. Yeah, there you go. It should be... Oh, engineering. I think that's... Oh, that is a tag.
Yep, that's tag 2.
Sweet.
Okay.
There we go. Now we're fully updated. Okay, now we're in the game. So, what are we going to do today? That's a good question, was what are we going to do today?
Well, we should demo, I guess, show people what we did last in hardware. So we should bring on the unit and show what we did.
Yes. And we will also show, we should show the thing that you made with the gear reduction.
Okay. Oh, right,
that thing's crazy. Because we showed that a little bit last time, but we, it's just something that kind of takes a useless part that we have, which is those really fast spinning motors, and then actually making it into a functional part, which is super cool.
Yeah, so just to let people know that there's these little DC motors that you can buy really cheap. So these are Type 130 motors. Unfortunately, I don't have one in it. It's already kind of embedded. It's only about an inch high or so. These are cheap. They're DC motors, only about maybe 50 cents to $1.50 on AliExpress. Give them anywhere from 5 to 8 volts, and they'll spin those spins at something like maybe about 3,000 RPM or so, but very little torque. So you find these in stuff like little toy cars and little toys, for example. Hand mixers, for example, as well too. You find these little motors because they're cheap, and they're decent enough. The only downside of using these motors is that they spin so quick, but they have very little torque. So if you try to put a little wheel on them and try to make it work as a little, directly, all going to happen is that the little wheel is just to spin its place. It's not going to be enough friction. It's just going to just spin in place. It's not going to push it very, very far. So what you need to do, if you want to use these in stuff like a toy, you have to reduce the speed and increase the torque. And that's what this whole box is. So this is a design that I found on Thingiverse. I have to look it up. But anyways, it has a series of 4 gears inside. Each gear is a 2-to-1 gear ratio. So 2 times 2 times 2 times 2, 4 times 16th. So this output gear spins at 1/16th the speed of the input, but also 16 times the torque. So when we hook this up to a battery, we can actually see it spin. And previously, we weren't able to make these motors work with little toy cars that we had for student projects. And we only realized in retrospect that they spun too fast. No torque.
They spun way, way too fast.
But now that since we have this little reduction gear hooked up, I can actually, so if we could hold that in place. And so there's the output gear over there. I'm going to just attach 2 nickel metal hydride rays. These only provide a total of 2.4 volts. But we should be able to get some activity. Oops. And there we go. So it sounds quite powerful. There's a flag on here, but the shaft is spinning maybe about 2 reps a second or so, I would guess.
Yeah. You can hear from the noise. It's actually doing a lot of work.
So that's at 2.4 volts. So essentially, I can give it another nickel metal hydride battery, give it 3.2 volts. I should increase the torque even more. And yeah, that should be the goal for this. At least for me, is going to be use it for robotics projects. The drive gear of some kind of robotic platform that goes around.
Yeah, that's great.
Kind of like a Roomba or something like that.
Is it possible to make it into a stepper motor?
You kind of can. So what it is that someone actually had design where the same person came up with this drive box. He actually had a separate design where you put a little encoder wheel on this. So therefore, and using a pair of infrared, detectors. You actually detect where its position is, and and put a little Arduino on there, and therefore you can detect what angle it's turned to. And so,
oh, that's sick. That's awesome.
Do pulse width modulation, make it turn to particular angles.
That's great.
So that's another goal to do. So then you have kind of cheap little, geared motors for yourself that you can figure out what angle is.
Give me a second. I'm just posting to Twitter and Facebook and stuff like that. I don't know why, but my Discord is not connected to my stream stuff anymore. I guess I'm gonna have to reconnect it. But here, let me make a quick post. We're working on the
Stream Deck Part 2. DIY Stream Deck.
Okay, there we go. Post. I'm gonna actually grab this. I'll just use that same one on my Twitter. And bada boom, it's all tweeted. Okay, so now let's talk about what we did. I'll go grab the components so we can actually demonstrate what we did last time.
Okay, and I'll just give a recap while you do that.
Yeah.
Okay. So the goal of our little project is to create a Stream Deck for yourself. What is Stream Deck? Well, of course, everyone's watching on Twitch right now, and so of course everyone uses stuff like OBS Studio, and you want to be able to switch back from one scene to another, play back music, do various things. You want to trigger various kind of things happening during the middle stream, and of course it's a little hassle. You take your mouse, try to click and do stuff. Instead, what a lot of streamers do, they have themselves a Stream Deck, a little box, series of buttons connected up to the computer. So what do? You press a button to trigger certain things happening, like switch scenes, pause playback, whatever. And if you do nice Stream Decks, have the ability to program each of the buttons. So, for example, you can program a macro that pushes this button, this pushes maybe to your above scene stream. Another one pushes back to your game stream. Whatever. It's up to you. Whatever you want to program these buttons to. You can buy them. They exist. But usually they're kind of pricey, like over $100 typically.
Yeah.
So our goal is...
which is kind of surprising considering that it's just basically a bunch of buttons that act as keyboard inputs. Which, it seemed to me that it should be easy enough to fake that kind of thing. So that's what we're going to do today, is we're going to try to write a program and emulate some of this keyboard presses. That's what we were trying to do last time, and that's where we have the majority of our problems.
So to kind of recap what happened last time we actually got a prototype done in hardware. Our hardware is based around the Arduinos, which a lot of people hopefully know about. So the little kind of microcontrollers that you can get really cheap these days. The original ones, the Arduino Uno. Originally, their open source electronic software ecosystem lets you design products that need microcontrollers. The original ones were roughly in the $20 to $30 range. Really nice in programming environments. It's essentially a variant of C++, but it's really accessible, really easy to get into projects. And if you kind of Google search, look on YouTube, Arduino, Arduino, you'll find tons of stuff out there these days. Everyone's using these days for various hardware projects because it's just so easy to use. We're using one.
Yeah, sorry, let's bring this down so we can see what we're doing here. So right now I've got the Arduino here, and last time we unplugged it, but basically I have the buttons very easily wired out to 8, 9, 10, and I have the LEDs wired out to 11, 12, 13. So if I power this up, it should just work. Oh, do I have a longer cable than this?
We extended it last time.
I know, but this time I'm using the extender for the camera.
We should. I'll search for another USB cable.
Yeah, there should definitely be another one downstairs, or if not there, maybe I got another one up here somewhere. Interesting. Well, Alan?
Yep.
I think I remember where the cable is. Did you find one?
I found a cable. I don't know if it's the right kind though, because there's a Type A cable.
It just has to be one of those square serial cables.
Okay. Yeah. In this case, this might work.
Oh, that's perfect. That should be perfect. That's a lot longer than the one we had. The other one that we have is great when we like using it with just a laptop, or if I have to bring it to class or something like that. Speaking of which, we used to run classes at Roundhouse Community Center, and then COVID happened. But here we can actually push this stuff back a little bit. So
people can get a better view of it as well too.
There we go. And hopefully, you just press the button there. You can see that each of those has a toggle. So each of those lights up there actually gets toggled off of these buttons. Now, the thing that we had a lot of problems with last time was that there was like a certain delay when you were pressing a button, and we ended up having to make a debounce program so that you could do things like this. Turn two of them on at once, or like this. Normally, that when we press them down, it would toggle every half a second, so you'd end up holding one button down, and it would turn the same light on and off, on and off, on and off, cycling it on and off. But and like when you held one button down, it would make it so that another button wouldn't function anymore. So now you can press all three buttons, and you can even release one if you want. It basically just all of the inputs are being read simultaneously. So that kind of is that asynchronous
or actually they're actually all handled independently. So in terms of asynchronously, yeah. So what's happening is that if you don't actually program an Arduino, there's this thing called a loop, and it's a little bit of hassle in the beginning when you're learning how to program to get your thinking wrapped around doing many things at once, and especially for stuff like button presses. So we mentioned in the last stream that your friend Bizarro.
And we dedicated the last episode to you, Bizarro.
He's Jordan's friend who's a magician down in Las Vegas.
Yes.
He actually had an escape room, which you should go and check out sometime. But he needed some custom programming done for some triggers on his escape room. And one of the hassles in trying to make it work himself is that he's trying to trigger things happen, but it didn't work because you get fluttering happening because of something called debouncing. That needs to occur, and another thing that happens was stuff called, I guess, triggering. That if you want to press, you want to be able to release, and only one press to make it go off. You want to be able to toggle, which if you don't know how to handle it, it's a bit of an issue. So I believe I'm getting a little glare. I think it's kind of showing up. I believe. So I hit toggle.
It doesn't seem to get those colors very well. But.
Yeah, unfortunately, it's whiting out. So we had, but people I think have a general idea. Even if they don't have the color, they can see it goes off and on.
Yeah. So we've got three different toggles here now. Now we've got to figure out what we want those to do and how we're going to try and read that information. So we tried literally turning the Arduino into a keyboard last time. Yeah. That's what we did. We tried to legitimately reburn the firmware to make this thing read as an Arduino as a keyboard device.
A fake as an actual keyboard, that you type on.
And when that didn't work,
we ran into issues.
We kind of we ran into a lot of issues. If you guys want to watch that, you guys can go back on our channel and watch. But we basically
but don't watch it because it's a waste of your time.
Yeah, pretty basically.
So instead we're doing a different route this time. In this case, we're going to do we're going to keep it as Arduino. In this tape, we're going to handle the stuff in software instead, which is fine. Again, it'll help us learn about software now. And it's a little more applicable because we had done what we're going to do last time. It would essentially have been no programming on our effort. Essentially, it's a pre-designed library that you can just burn the firmware onto your Arduino, and it makes it behave as if it's a USB keyboard. A little less interesting. It'll be very easy, but
today is going to be a programming episode because we're basically going to be working with I guess Python.
We're going to Python. Yeah, we're going to Python.
So basically, what we'll have here is a bunch of stuff that's coming in on our serial port, so we don't have to take that information and make it useful. If we were just using the normal keyboard inputs, we could literally make, like, for example, this button press K or something. Like, it literally becomes a keystroke if we could get this thing to fake being a keyboard. But because we can't, or not that we can't, we had some issues and it for some reason just didn't want to work.
Because of Windows.
Yeah, mostly Windows. I'm ready to blame Windows. So this time we're going to try something a little different, okay? So give me a second. Should we make this a little smaller and then we'll...
we should create a whole new screen. I guess
I did. So I created a new one, switch programming.
So I guess we want... Okay.
And I'm going to create a filter here so that you can see past us.
Yeah.
Let's do, let's just chroma key.
Yeah. You probably want to put it into the lower corner because you want to actually program the
right. So let's do that. Yeah. So let's just give me a second. I'm going to do 50% opacity. So we're like halfway gone. We're here.
Yeah.
Halfway gone. We're all the way gone. Okay. So then we're going to add in here just our display. Or yeah, we'll just add the display so that they can see into the future. Unless I should just make it do Arduino. Oh, actually, never mind. We'll just do the whole thing.
Okay, we're gonna make
Windows desktop.
Well, I guess the desktop for now. At some point, let's make a cleaner one. Let's actually make it. We should open Chrome.
So if we open up Arduino, we can just have it just be the Arduino window. So if I open up Arduino, then I can go in here, add display, or not display capture. We want window capture. Now we want Arduino.
So we're gonna be switching back between.
Oh, that's pretty good. The only thing is that you can't read the white on the white.
Yeah.
So because it's not underneath everything. I gotta go over underneath everything. So here we go.
So let's actually resize, and maybe we should
move the total follow count and everything over.
Maybe, yeah.
That means we're just gonna be saying. So we'll go like that.
Actually, it might be okay. I guess we can still see stuff.
If we go into Stream Elements, I can create a new one. So give me a second. We'll go back. And we'll create a new overlay. Again, I apologize, guys. I've been creating new overlays just for our different streams that we do. So we're gonna create a new chatting overlay. Duplicate this one. Twitch overlay, awesome. And we're gonna edit this one. Edit. And this one's gonna be our new Twitch programming overlay. Okay, and we'll move the total follower count over here, I guess.
Yeah, that way we can see code all clearly on this side, and all of the stream stuff happens on that side.
That sounds good.
Yeah.
And over here, this is our followers, so we don't need this anymore. Okay, that's probably good. Let's just save that and use it. Yeah. Come on, I'm trying to get that. Like, oh, come on, why it keeps snapping? It's trying to be helpful.
Yeah.
I'm just gonna get rid of that. Fuck it. Sorry, guys. I swore. I didn't say it was going to be a safer work stream. Okay, so here we go. Twitch programming overlay. We're going to go in here and we're going to remove that stream overlay. And should we change the color of it, maybe?
Make it darker because I guess most programming environments are going to be white, I guess.
Stream elements for programming. And this one's going to have this overlay, which is a different source. This one. Copy URL. There we go. Oh, and then we actually want to make this the full size of the screen. So 1080. There we go. I think that's right.
Yeah. There's.
Did I go too far?
No, it shows up.
Oh, yeah, it's too. But we want it to fit the screen now. Transform. Fit to screen. So is that okay like that? I mean, it's probably fine, right?
That's good.
Okay, cool. So now we can continue on our little journey and do some programming. So we have our code in here. This is what we wrote last time in order to get things working. And because we did it last time, and if you want to learn like really in depth how we got to this point, that is something that you may want to go watch the last stream for, because that won't be a waste of your time.
And later on, we're going to actually post all this code to a repository in Git as well too. We'll include our Python code as well as this code as well too, so you'll be able to find it once we get all that done as well.
So that anybody else who wants to try and make one of these stream decks can, of course, use what we made and save yourself some trouble. But basically, all it does is that in this loop here, it reads each of these buttons ticks and then tells us whether or not each of them have been pressed. If they've been pressed, then we have some other code over here that changes the state and allows us to kind of read everything all at once. It seems complicated, but really the most complicated part of this was the fact that we made everything really nice and used some classes to clean everything up. Like this stuff here is... This was working pretty good. Also, it's kind of neat that we just have like a button switch, like we can determine in this class function, or sorry, not the class function, but the call.
Yeah, we initialize each dbounce object which handles a button, but each button can be customized at the point we create it. So we can give it first element is the actual pin of the Arduino. So if you've been following along, every single one of these pins on Arduino is programmable. We chose, in the example, the top line pin 8 is supposed to be the red button, or i.e. triggers the red button. And then pin 9 triggers the next button, and pin 10 triggers the button next. And then, of course, there's also another pin which we configured to be actually the LED output, which lights up that particular color. So we kind of worked all that out last time and created something that you can create buttons, controllers ad hoc whenever you needed to. But the additional thing we did last time is that if you kind of go to the code, is actually because we need to have these buttons to go to computer, which then triggers things in our OBS Studio, whatever kind of streaming software we're using, we need a way for this to communicate with computers. So also, additional thing that this software does, it communicates versus what's called serial input-output to your Windows computer or whatever computer you have. And so that's already built into the software we have. And now the goal this week is to handle the computer end, to read from the keyboard and then trigger things out. So we're going to handle that today.
Yeah. All right. So I guess what we need to do is I need to go into OBS. I'm going to take this Twitch program one. I'm going to create one for doing Arduino, one for doing
Python.
Yeah, Python. I'm just going to duplicate it. Dupe. One of these days I want to do show you guys a tutorial of how I got all my OBS and everything set up.
Let's also create another environment for just a web browser for just Chrome as well.
Oh, yeah.
Want to switch back and forth between Chrome as well too. So.
And this one's going to be duplicate Twitch Chrome.
Yep.
Okay.
That way people aren't going to see our ugly background every time we switch over.
Right?
Okay, let's actually do the Twitch Chrome because we need to do some things.
Yeah, that was right.
Chrome. So in this
so
case,
I'm going here. Sure. We want to remove Arduino and we want to add in a different one. We want to add in our window capture, and this one will be Chrome. No, we want Chrome. Okay. Okay, is that... Oh, I think it needs to be made to the transform to the screen. There we go. And it should be underneath everything. Okay, so now we're in Chrome.
Okay, so now we need to set up our program environment. So for people who don't know, Python is a really great language to learn if you're a beginner. It's also a pretty major language out there that, for example, it's heavily used at a lot of startups these days because it's just really kind of fast to program. Google uses it heavily. A lot of major startups use it. For example, the original Dropbox was written in Python. So it's a nice language to learn.
It's like a really nice language to learn. It's very friendly, in my opinion. And it just makes programming fun because...
Should probably also add to
I was going to mention that the reason why I wanted to stop here is mention that when you start and open up this installer, the defaults will be install launcher for all users, which depends on what you want to do. I think they may
not see it because there should be only seeing the browser. We should have shared the actual desktop.
Oh, you're right.
Yes, okay, so we should let people know.
So should I make a new one for desktop?
Twitch desktop.
Right. Desktop. And we'll just... Because, I mean, you don't need to see everything all the time. Sometimes they're going to see the awful background, but sometimes they're not. We'll just use display capture, Windows desktop. Okay, so here we go. We've got the install for Python. So this is the big important thing here is that when you come into here, if you don't have Python 3.9 in your path, you won't be able to do things like use CMD on it.
Yeah, it's great. The one thing you really need to use command line, and you want to be able to include it to command line, and you have to add this to path. So make sure you do this.
Yeah. All right, so let's install now. Also, it's going to ask for administrator features. Just let it. It's important. So let it go. It's going to ask you if you can do whatever, and it will install Python to your path. Now, actually, maybe you can explain why that's important, because I don't understand technically why. All I know is that, like, if you don't have it in your path, you can't open up a command window and type, for example, Python, and then type the name of, like, the location of a file to run a program.
Okay, well, so this goes back to the old ancient days and stuff. In the antediluvian times, when people had no, I guess, GUI. A mouse? What is this? Crawls across the floor. That's what the mouse was. So the only way you can work with a computer was with a keyboard and a screen. And so, of course, those were the ancient days of DOS. Ask your grandfather about that. He'll say, "Oh, DOS. I remember those days. That was a terrible time." But funny enough, it's actually turns to be really useful to just type commands in, because you can get things done a lot faster, more succinctly by just typing commands. And then you have stuff like a console or terminal. That's what that is. Okay, you type commands. Okay, well, what commands does it run on a computer? Well, the thing is that you have software, and software in Windows and the other programs are executable and stuff, but it needs to know which things are, because a text file is just .txt. That doesn't run, but you need a program like editor, edit.exe, to open that up. But on a computer, there are a bajillion places where you can have stuff. When your operating system is going to search that bajillion places, no, we shouldn't have to have it do that. Because you type in run edit.com, it runs this malware instead of the proper one. So a path for operating systems is the path to, in other words, the directories where actual executables or should be run from. And so we install new software. Now everything runs because Windows needs to know which path to which programs should be done. And this is what the paths, what's called environment variable does. Okay, hopefully you understand that. So this is why we had to include the path variable in the installation, because we want to be able to type stuff in, and we want to be able to have Windows find that stuff. So we need to tell the installer to put down our path. We'll see more practically in a second. Don't worry about all these details. It's just filler and stuff.
The path is one of those things that if it didn't automatically install it, I would have to go into my system and manually change some stuff, which is you can Google how to do it. It's really nice that the installer has that.
Yeah, so we recommend you do this in the beginning so you don't have to do that later.
Okay, so now what's the next step? Well, we are now going to... Oh, sorry, that was PyCharm, right? We have to install PyCharm?
We're going to install
We should explain what that is.
Okay, well, the thing is that when you first install Python, it includes actually a programming environment called idle. It's a real joke because Python's named after the snake. No. It's named after Monty Python. And so IDLE is the name of the Integrated Development Learning Environment, IDLE. I wonder, Monty Python, who was in it? Oh, Eric Idle.
Oh! No way, I didn't even know that, Alan.
So the hope, and of course, there's a famous cheese shop sketch. And of course, for the longest time, the way you installed new software to the Python environment, new libraries, was from the cheese shop.
That's really funny.
So there's quite a few puns, I guess, involved in Python. So it's part of lore. One day you'll be part of it.
Yeah, I know that there's like a bunch of like little Easter eggs in it too.
There's a bunch of Easter eggs. Yeah.
Like was it import gravity?
Yeah.
Okay, so what's the download PyCharm?
So what happens? PyCharm. This is an alternate environment to kind of create your Python program. And what it is, it's really nice because it lets you develop really large programs. It's able to use what's called version control, because a lot of times when you're creating a program, you can make changes. And if you have no way to track what changes you made, it's really easy to get out of sync of what you've done or change things you realize you shouldn't change. So this is where version control, it lets you go back to previous versions easily and more efficiently. Also allows you to make changes without worrying about clogging something that works. So version control is a really important thing in actual real software development these days.
Yeah.
The other thing that PyCharm does is actually it creates the ability to edit many other files beyond just Python. It's able to work with JavaScript as well too, and HTML, and it's able to organize your file structures. A whole bunch of stuff it's able to do, which makes developing large applications easy.
That's great. I've never used PyCharm before. So we'll check it out.
Yeah, so
I'm also on what's called the 3D print finish. So give me a second. I'm going to be right back.
Okay.
I'm going to head downstairs and check that out.
Yeah.
Should we print anything for the project today?
I don't think we need anything to this. Today's
not yet, right?
Yeah. So
I mean, I guess next week.
Yeah.
We're gonna do
custom box.
Custom box to make that.
Yeah. So once we have the software and hardware, again, this is prototyping. One of the things when you do something, don't try to make it perfect the first run through.
It would never be perfect the first run through.
Because
just try and get it to work.
Yeah, you're going to encounter problems, and the key is that you want to encounter problems. You want to encounter problems quickly so you can defeat the problems. So you don't want to commit yourself to a whole bunch of extra work that you're going to throw away too soon. So you just want to make it work first, and that's what the goal is.
Okay, I'll be right back.
Okay, sure.
You can take over if you want.
Sure. So right now we are.
Right now it's focused on Chrome.
Chrome. Okay. So right now we're going to install this program environment PyCharm. So of course you just go to the website. In this case, if you Google search it actually ends up at jetbrains.com. This is JetBrains, the company who manages and actually produces PyCharm. Also a whole bunch of other IDE tools which are really nice. People should check them out. In this case, to provide two versions, we're actually going to use the community version, free and open source. So we're going to download that first. Of course, hit that, wait for it to download, and it's happening. And just be a few moments while it actually downloads.
Okay. And yeah, the 3D print is working great. It's really neat. Like a 3D printer, if you guys are going to make your own stuff, 3D printer is a must. You can make so much cool stuff with it. And
it's cheap these days relative to what it was a couple of years ago. You can get a pretty decent one, a low-end one. The Ender 3 Pro is a really decent model these days to get. That's roughly about $300 or so, US approximately. But you can, plus or minus $50, it's in that ballpark. There's various kind of clones out there as well, too. You can get on AliExpress or Banggood or eBay and stuff. Find a reputable seller, and you should be getting in the $300 plus or minus $50 range. Yep, we'll install PyCharm.
Okay. This is really cool. I've never used this PyCharm program before, but it has like version control and stuff in it.
Yep.
Neat.
So we actually want to update the path.
Oh, we should open up the thing so we can show what we're doing.
Oh yeah, so we're going to go back to desktop again.
So we're here.
Yep.
Okay. Let's go back to the beginning so we can see what we're doing. So next. Destination folders, whatever.
Use the default.
Any of this stuff?
Let's actually add launch stars to the path. That means I'm trying to think. I think everything else should be fine. We don't need a desktop.
Create associations?
Probably not.
No, because we want the default Pi to open up, right?
We want to maybe use the Python console.
64-bit launcher?
That's just a desktop shortcut. We don't really need that really per se. You know, let's open up them.
Add open folder as project?
That's a context menu. We don't really need that either. We can open up JetBrains.
Okay, JetBrains, start?
Yep.
Okay, cool. And is there anything else we need?
That's about it at the moment. Oh, yeah. So we're going to demonstrate how to set up an environment. Don't worry about this. This is just kind of boilerplate, the first round. So if you're just learning Java, don't do what we're doing. Just go to the Python web. Sorry, if you're learning Python,
Java,
just go to the Python website. Google search on how to learn Python. There's tons of stuff out there. You can go to, for example, Khan Academy. And there, I think, let's see, I think W3 School offers a whole bunch of tutorials. There's tons of tutorials out there. It's a really good language to learn. But we're assuming in this case that you have a minimum level of Python familiarity. If not, sorry.
Yeah, pretty much sorry. But we're gonna do our best here to try and explain how things work. If it doesn't make any sense, I'm sorry, but we'll do our best. We'll do our best.
We'll follow up later with more tutorials in the future.
Yeah.
So this is just this particular project. We don't need to reboot, so we should be able to do this. This just sets up the path.
Yeah,
so,
good.
Yeah, we can finish.
Okay.
Yep. So we have the PyCharm environment set up.
You say hey to my friend. Okay, so
let's actually fire some stuff up. Let's go to
Python?
PyCharm.
PyCharm?
Yeah. Let's open that up, and we'll add this to our programming environment.
Oh my God, that's confusing me. Okay, so give me a second. It's starting up, I think. Just give it a moment.
Yeah.
We can watch Magro stream for a little bit. I'll turn it down so I don't get. Yeah, my buddy Magro's been playing lots of games. If you guys haven't seen his channel yet, go check him out. He's awesome. Okay, he's playing Yakuza right now. This game is really neat. It's a level 15 Twitchy streamer. You guys, can you guys see that? Level 15 Twitchy streamer and a host. Somebody's hosting a Twitch stream. But like, guys, they got meme names and stuff. You guys gotta check them out. Okay, this is my buddy. Okay, so sorry. What were we doing again? Oh yeah,
I believe we're firing up PyCharm.
Yes.
Open.
Okay. Confirm. JetBrains. Don't send.
Don't send. I guess.
I'll send it.
Help them develop the code better. This community version, it's community supported. Might as well support community.
Yeah. New project?
Yeah. Let's open a new project.
Okay. Give me a second. It seems like it's still loading. Okay.
I realized we shouldn't do this quite. Or actually, maybe. Yeah. Actually, we want to create an environment itself. So we want to create a virtual environment. So we want to give it what project? So instead of calling it Python project, we're going to call it. So I believe we should call it what
Stream Deck.
Stream Deck. Yep. And yeah, we do actually want to create a virtual environment because we want to be able to install new packages without cluttering up our user one. Yeah, I think the default should be fine.
You hear a global site?
No,
right?
No.
We don't have anything like that.
No. So yeah, we want to make it. Yeah, this
create main.py welcome script.
Yeah, I guess we'll do that. Great.
Okay.
Let's see here. Oh, this is just a tip. We should be able to close this. We don't need to show tips.
Next tip.
Yeah.
Live tip.
We can close this. Yeah. All right. So now it's creating a virtual environment. So people who are Python programmers, one of the great things about Python is it has this great library for itself. The built standard library has all sorts of stuff that's nice, does a lot of work for you. But of course, you want to install other stuff sometimes. For example, if you want to create games, PyGames is a great library to install. If you want to manipulate pictures and stuff for images, well, we actually have PIL, for example, the Python imaging library. It's nice to install. However, and of course, if you want to do web development, we have Django, we have Flask. Those are all installed as packages and usually use pip to install. However, if you're creating various programs, sometimes you don't want to have every single library all the time in every single program that you write. So what is that? We have this thing called virtual environments, which is a huge part of modern Python programming. You create a virtual environment. It essentially isolates a Python for you, and you add whatever you want to it, but it doesn't affect any other version of environment that you create. So this is what we're using right now, virtual environment. Creates a folder called VN, which holds all the libraries that customize this particular installation of Python that we have.
So let's go to this one, and we're gonna do that.
Yeah.
We're gonna remove that.
We should add them both.
And add the window capture. This one's gonna be PyCharm.
PyCharm.
Yeah.
Yeah, that looks like it's fine.
Boom.
Okay, there we are. Okay, so discussing what we have. So here it goes. So in this case, it's an integrated development environment. So now that we have this here, what we can do is that we should talk about what we have. So we actually have over here on the middle, this is actual code right here. This is actually your Python program. It already kind of gave us a boilerplate default. And so that's nice syntax highlighting, a whole bunch of nice stuff that makes it easy to program.
green button in the gutter to run the script. Really?
Yep. So actually run this as is. And it opens the terminal and runs the program for us.
Whoa!
Yeah.
Neat.
Yeah.
Neat. That's awesome. Okay, so the first thing we want to try and do is we got to try and figure out how to get the inputs from this thing into here. So we're reading somehow the serial from Python.
Yeah. So in this case,
should I just Google it?
Yeah. In this case, let's switch our environment over to our
Google.
Chrome. Yep.
And we're gonna hop into Chrome here. We're gonna type in how to read serial
or Python serial library.
Python 3 serial library.
Because it's not built in. But luckily there is at the very top list PySerial.
PySerial. Neat.
So as I mentioned before, Python is great because it's all these libraries out there that can actually include if you can't program yourself, some of the library already existing out there, so you can install it. The question is how do you install it? Well, here it is. If you look here from PyPy in this line, any library can be installed on the command line. In this case, we have to type Python -n install PySerial.
I find it funny you call it PyPy. Because for a long time I called it PyPy.
Or Pippy. I call it PyPy. I don't know the pronunciation because I only read this. I never heard anyone say it. So
yeah.
Who knows what it is?
PyPy or PyPy. It's like GIF or GIF.
Yeah.
Guys, comment down below whether or not it's GIF or GIF. Okay?
Or is it PyPy?
If you're watching this on YouTube.
Or is it PyP? Or is it PyPy? Which is it?
PyPy. No, I'm sure it's... The first one is definitely Pi because it's Python.
Or is it P?
Pipey?
What is it?
PyPy.
Who knows? Does someone out there know? Let us know in the comments.
Yes.
But
okay.
we won't be able to understand because it's comments, just checks. Self-interpret again. So spell it phonetically.
Yeah, we always just read it. We never actually say it.
Okay,
so
but how do you install? Well, that command installs a command line. How do we do that? Okay, we just highlight this, copy this.
Okay.
Control C.
And
then we switch back to our
command prompt.
Command prompt. You can go CMD.
Oh, we got to go to the desktop that gives it.
Yeah.
So that you guys can see what we're doing. Okay, here we go. Now we're taking control.
Let's just check if our path works. It should. If you just type Python.
Should we try that one?
Actually, you should install because we don't install on the global.
So Python.
Let's type Python. Let's see. Make it work here. And no, it's not installed. It looks like it's.
We didn't install it properly because we installed it from the package instead of installing it from the store.
I guess because it hasn't updated path, we need to reboot to
Should we get it?
Path. Let's not. So we should be able to do this regardless. We already have the IDE, so actually we can do this in PyCharm as well too. Let's go back to PyCharm.
I mean, I installed Arduino through the store.
Yeah.
Should I install this through the store too?
Well, let's see. We can do so, but we already have a Python environment.
Although I feel like this is going to mess with our environments because we're going to have 2 different environments installed.
Yeah, so we don't need to. If we reboot the next time, we should have Python on the command line, so we should be fine. Okay, so let's just switch back to the Twitch programming, Python programming screen because we want to get back to
this one, Python.
Yeah, Python.
Okay.
Right. So, luckily enough, in this here, we actually this is why PyCharm's so nice. If you look in the bottom of PyCharm, the very bottom row, we have all these things: run, to do, problems. Hey, a terminal. Let's open that up. Window.
Ooh, can we run that there?
Yes. Hit that.
But this is that going to install virtual environments?
But you've noticed it's VN that tells us we're in a virtual environment. So we're not going to clutter up our rest because automatically we create a virtual environment for ourselves.
That's clever.
If we hit enter, it's found.
No way!
We have the PySerial library installed.
Okay, well we better go take a look at what that actually means. So we'll switch back to Chrome.
So let's actually add this to our environment. Add a copy of Chrome as well too.
Yeah,
that we can have both. So actually, let's go to the Python environment. Let's actually add Chrome to this as well.
Okay. Add window capture. Chrome.
Yep. And we can resize this, so then we can have both environments in this.
Okay, so how should I make it smaller?
Yeah.
Like that?
Or you can resize actual real window itself, so it's...
Oh, I see, I see.
Yeah. Make it,
make it like
screen.
that?
Yeah.
Is that better?
Yeah, what do you think?
That's pretty good.
Yeah, that's good.
Just, we got to put it underneath everything. Let's put it like there.
Okay, now that we've installed this, we actually don't need... we can actually bring on top of the terminal because let's bring it down there. So we'll leave the terminal open, but we'll just move that down to that same position. That way people can actually...
Which one?
Yeah, let's move that down over here because now, of course, I'm going to be able to refer to our main code and be able to refer to Chrome. So actually just move that down to here.
Oh,
bring
crap.
it down. Yeah.
Chrome?
Yeah.
We want to put it over here?
Bring it down. And that way we can see code here and over there.
Okay, I see,
Yeah.
I see. So we go over here and we're going to go look at the library.
We're
already in the library.
So we're in the documentation. So we can actually go and we can view the installation, which we have.
Installed.
And then we actually have, we go down, I believe we may have hit next and maybe actually get into the, here we go.
Whoa. So the first thing we want to do is import serial. So let's take this line of code here, stick that into our program.
We probably want to put in the main, or sorry, yeah, it goes outside. So we import. So first thing we have to include the library, import serial, and it looks like for the code we have to create a serial port object.
I'm just making sure that we can see everything.
Yeah,
I think that's good, right?
Yeah,
that should be okay. So we've got this, and I'm actually going to put it
literally
over here
where it is too. Yeah,
so we can kind of see what's going on, and then
up that, and bring Chrome up from front. So this way you can do. You right click on the window, and you can go. Oh, it looks like it doesn't do that. So I know that sometimes you can actually put set a window on top. It doesn't look like it does that. Okay, actually we're not gonna worry about that.
Okay, we'll pull it back and forth so that at least we know where it is.
Yeah.
But now we have import serial, and let's go back to the web page here.
So it looks like we have.
Should we just grab all this whole thing? We have to go line by line because we've got all this wingdings in front.
Yeah. So we should just type. So first is we create a serial object. Then we can
def tty USB 0. Is that gonna specifically open that port?
Actually, in this case, we're gonna because we're on Windows, we're gonna actually be COM3 or whatever that is. We'll have to look up what it is.
Yeah.
Yep.
So how do we know that? How do we know which one?
Well, we have to look up the device manager. We see what COM ports are.
So should we open up device manager?
Yeah. So or actually, we look up the Arduino IDE because that'll tell us which COM ports we have available.
Oh wow!
Yeah.
Give me a second. My chat is not appearing. So maybe I should change the. I'm going to change that really quickly. Because I realized that because we have everything on white, because Stream Elements is in white right now, we're not going to be able to see any of the anybody's words.
Okay.
Oh come on! I'm not logged in right now. Okay, my overlays. Edit. I just gotta change the Twitch chat color.
Red, perhaps.
Oh yeah, that'd be good. Let's do red.
That should stand out against black or white.
Text settings. Here we go. Red. We'll do red. That should save. And just let me just test it once. So let's go into the chat and say test. That work? The video's buffering weird. Oh, it's still lagging. It's still trying to catch up.
Okay.
If we go into here, we can see. Oh, it says Woot still, but it is not saving it. Am I not using the programming overlay? Stream Elements for programming.
Oh, I think it's because the updated the URL might have changed possibly overlay.
Yeah, maybe. Let's go back.
URL.
Copy URL. Seems to be the same though. Arg. Why is it still? That's bizarre. Did I not change the freaking text?
I think it's just it's not. So there's two parts: the text of the speaker and also the text of the actual.
Oh right, yeah. So
the actual
settings,
the actual message
text
itself.
settings. So that's which one is this one? Text stroke. For some reason I thought it would change the color.
Okay.
Oh, I see up here. Maybe it's this one. Yeah, there we go. And what is this one down here?
And that's the logo of the person saying the stuff. I think.
Okay.
Like the speaker, and then the actual text are actually saying.
So what should we both be red?
Maybe it's like different color, maybe dark blue or something, or dark green, or greenish perhaps. So that might work better.
Sure. Let's try that. Test it out. Test 1. Test 2. That's better.
Okay. Yep. So that should show up against either white or black, hopefully.
My concern is different now. I'm worried that that's going to detract from all the... We should make that a little smaller. Let's go up here. Let's make this like 24. That's a little better, right? Because I usually make that huge because I want people to read everything, but in this case, that's going to make it really hard for people to actually see what we're programming and stuff. So, and I'm going to make the text box even smaller. So we'll just remove that. Settings. What's the settings of this bitch?
It's position and size.
Twitch chat. Position size. There we go.
Yeah.
And we'll make the height like 250, I guess. A little smaller. That way it's only taking up the bottom of the chat. That's a little better. Perfect. Okay, so now we're coming back into our thingy. Ooh. Okay, so we've got our thing here. We're going to try and figure out what we're doing.
So let's just erase the def print high and the stuff. So we're just going to do some...
Oh, I see this thing that's changed size again because I did that to it. So we're going to go to PyP and then...
Okay, well, let's just clean up our code. So
PyCharm?
Yeah. So again, here's our existing code.
We don't need this, right?
We don't need that. Don't need that about the green button.
Pass?
Yeah. Well, you want to create a function for ourselves to actually execute. So the main function, of course, we want to put it in the main.
So we want def like tick
or
loop
main for now, I guess, or just call it main and colon, and then we actually we're going to create a serial port. SCR equals to serial. So we need the name of our.
Oh, I'm just trying to remember what that is now. That was in here, right? Nope.
Yep.
Here we go. So
we
just
create
grab
a
this
variable. Yep, of that name.
So it's open the serial port, and should we check our device manager to see what that's actually called now?
Yeah, we're going to check the device manager. So we go to the desktop environment, and then we'll open up our device manager, and we go to the ports. And there you go. It looks like it is COM port 6, COM6. That's USB serial device.
Okay, so we want to go into stream, not this one. This is actually our old one. We want to go back to our Python now. So COM6 is the one we actually want.
Yep.
So we're going to go in here. Is it not TTY? Is COM6?
I believe it's just called COM6. So
is it COM USB 6?
I believe it is just COM6. So if you kind of erase,
how do I know?
So Windows, it would just be COM6. COM6 colon. Because normally how it works, but we don't need the dev part. That's a Linux thing. So it's
we don't need this dev.
Yeah, we don't need a dev. That's on. If you're on Unix, you need to specify a device path.
So slash COM6?
No slash, just COM6 colon.
Really?
So I believe that's how it works. So we can double check. We can just go to documentation. We can actually Google search on.
Should we take this stuff too?
Yep. That prints out, but we have an ability to output anything. But we just want to be able to read whatever's there.
Okay.
Right. So we created a serial port. So then all we're going to do is we're going to do the next part, which is continuously read it.
So with serial.
So here's a bit of code that the first line with will actually attempt to open up the serial port, and if it works, it's going to assign it to the variable SCR. And then what happens if it's successful, then it actually executes the next couple lines. Okay. But we need to customize it, so we're going to have to get rid of that line there since we're replacing with this.
Which one?
The top line. Since we're going to use this with statement, which is a new addition to Python 2.3.4, that it allows you to gracefully open up a resource, and if it's able to then execute the code within this block. Otherwise, it just doesn't do anything.
So instead of this, we're going to use COM6.
COM6, and we're also set the baud rate not to 1920, but other to 9600. So that's the rate that we have.
9600. There we go.
Yep. And that should be fine, I believe. And then it's going to read. Actually, all we need is one at loop and just one read line continuously. So.
So while true.
Okay, or should we...
While running equals true?
We actually want to put that within the main statement. Within the... After
so maybe...
within the with.
Running equals true?
Yeah. We don't need a semicolon, because this is not...
Right.
Yeah. So...
Different language, guys.
Yeah. Okay, so inside that block that you currently have a cursor on, we're going to place... Get rid of those 2 lines. Read by 1 byte and read up to 10 bytes. We don't need those, because that's just...
Okay.
And then we just want to put a while running into there.
Really?
While running, yeah. Colon. And then we just want to print this to our console, which is print bracket and then sir.readline. Brace and brace. And there, so that's going to just continuously keep doing this until we kind of break up the keyboard. We should get rid of that line. We don't need that anymore.
Okay.
Yeah. So I believe this is just a trial thing to actually try.
Should we? How do we escape though?
In this case, we're gonna
press a key. Escape.
Well, we're gonna actually just press Command C in order to kind of quit the program, or just kind of close it that way. So in this case, we just want to get to work without worrying about it. However, we need to fix this up because we want to do main down here on that line. So if name equals main, we actually want to execute the main statement. Right, and there. So that's just as basic a thing as possible. It's just going to continuously read from the serial port if we've opened up properly.
So we try it out?
We're going to give it a try.
Hopefully it'll work. Yep. Run main.
And okay, it's doing something. Let's press the...
Whoa!
And it is. It's working. Although we want to get rid of the web browser if it's on. People aren't going to see this down here. Let's double check and make sure that people...
Oh yeah, we should close Chrome here so you guys can see what's going on.
Yeah. So right now we are running still a program. And you aren't seeing what's happening is that, oh, actually hold up to the camera.
Oh yeah, here, let's lift it up.
Sure. Because they do have a little camera in the corner. What is happening, we are pushing the button. So I'm going to press this button, yellow. I'm going to press this middle button, which is blue. I'm going to press the last button, which is red. And it is responding.
It's actually reading the different button presses.
Yeah.
And this is incredible because this serial input that we're getting here, where it says blue, red button, press, all this other stuff, literally is coming from the Arduino. The Arduino is the thing that's saying that to the serial port.
Although I realized we should actually, instead of saying press, just tell whether it's actually on or off, because we have this little light signal.
Yeah.
So we're going to have to modify our Arduino program to actually indicate the actual state. Whether it's
give me a second. That's Norman's
sure.
Norman's thing there. Do you want to take over for just a moment?
Sure, I'll do that. So I guess proof of concept, yeah, it works. We're able to read from it.
We're able to read it from it. Now the rest of it's easy.
Yeah.
I mean, not super easy, but it's still easy enough.
It's a good start. Now at least this major thing's working for us. We're able to read things from our Arduino and have Windows detect it and stuff. So now we're going to actually, next we're going to have to do some cleanup. A little bit of refactoring. We're going to have to modify the Arduino to actually tell whether a button is actually really on or off, because right now it's just telling whether it's pressed. So we're going to do that. We're going to switch our environment around.
Hopefully we don't get DMCA strike for the ringtone.
So right now, I just want to get it up and running with the Arduino environment. Let me just remove the current one, set this up. this.
So now we've got to change our code so that we're getting useful information from the from the Arduino now.
Mm-hmm.
Okay, that's some water. Or you want that up above? Yeah, just drag it up a level.
Yep.
Right now it's still a below Arduino right now.
And stream element as well too. The top.
There we go.
There we go. So now, okay, so now to redo this particular program.
Also, if we close this a little bit, then we'll have this nice black here.
Mm-hmm.
I like the black.
Mm-hmm. Okay, so now of course we actually want to change the round. So in this case, we actually want every time to press this, we actually want to tell the button what the status actually is. So we're going to have to modify our tick code.
So we're going in here, we're going to change up what we're printing out to the serial, because we want the Python program to take what we say from the serial monitor and then change that into some sort of useful command. So let's go in here. We got to find the serial press button here. Let's take a look.
So there it is right there. There's the press code right here. But instead, we're just telling what it's pressed. We actually want to tell it state. So then we need a little bit of if statement here. So
I noticed when we hack this thing, we should figure out a better way to do this with the remember we had string comprehension before?
Let's not worry about that. That's an opposition. I guess we want to make it quick and dirty right now, just to make it work.
Yeah, you're right.
Make it nice later.
So what we want is we want this not the stat. We want the status of it.
Yeah, status.
So instead of pressed, we want it to say on or off instead of press on.
Yeah.
So we want if
round bracket.
Yeah, if we're trying to read now the state of the pin here, which would be the toggle status. If toggle status.
So we need the this statement. This because it's this object.
Oh,
so
right. This toggle status. And I think that's all we need, right?
Yeah, that's true. And then it's curly bracket.
So let's explain this. Is that basically toggle status? If it's true, that means there is toggle status.
It's been lit on.
And if it's false, then there is not toggle status. But that's how we say that. Instead of just saying if toggle status does equal to 1, we're just saying if toggle status.
Because it's already Boolean, so it'll automatically evaluate to be true if it is actually true.
So if this toggle status is, that means it's true. So we should actually, I can add in here a little LED is on. Then we also want to say serial dot print
line.
This print line.
Yeah, because we want to end it. Actually, no, sorry. Again, we get rid
we got rid of the press. We don't need press now.
Yeah, we don't need that. So, but yeah, we want to print line. So
it will be say button. It says button name.
It'll give it a name, and then we want this to be space, and then.
So let me take a look at how it was reading out to this.
Sure.
Button, red button pressed. Do we need the button part at the beginning? We don't.
We don't need a red button part.
We really don't.
Yeah.
So we're gonna go in here. Get rid of button in here. So it'll say red button on. That seems nice and clean.
Yeah. We want to put space after, just before the on, because of course we print it. We say red button on. We don't want that, right?
Oh, right, like that. I see. Yeah. So space first and then on, and then if then we'll go in here elif or else.
Just else. You don't need to copy that whole thing. Just else.
Else.
Curly bracket.
Serial dot print line off.
And that's all we need. That's it.
Okay, cool.
Yeah.
So, I probably should have saved this as Stream Deck Test 4 or 5.
It should be fine.
I'll just make a new one. I'll make a new one. Just because from now on, it's
we don't have version control, but we will have version control soon.
Well, yeah, we will. We will. Yeah. Promise, guys. Promise. Yeah. We just wanted to get this one nice and dirty because this is going to be one of our first stream ones. And the hope is that once this is all done prototyping, we can actually use it on the stream. That way we can actually switch our... We can have it like switch our scenes and stuff like that.
And we can program as well too later. And for the Python part, again, we don't need to come do the reprogramming on the other side. So what happens? We have to hit, if you press Command Control C, you want to break this because we want to stop it from.
Did that do it? I think it did.
I think did that? I think or hit the stop button actually right there.
Oh, stop button.
Stop button. I want to break the code. Okay, there we go. Because we want to let go control of the serial port because now we need to go back to our.
Or do we know and re-upload it?
Yeah, upload it.
Interesting.
Oh, we have a glitch in the code. It doesn't like something. Did we? Or did we?
No, it's good. It's good.
No, it's a funny error a moment ago.
Just that's weird. Once this done, we're going to be going back to Python to do the rest of the business. But it's really interesting because you kind of have two different sets of code. You have one set of code that's literally the hardware trying to understand itself. And then you have another set of software, which is
trying to understand the hardware.
Trying to understand the hardware.
And do stuff in the
apples and oranges.
Yeah.
But this is really cool that we're like, this is just neat. I love this process of trying to get the hardware to do more than just, you know, be the hardware. You know what I mean? Now that you're getting it communicating, now it's interfacing with the real world. And then now it's doing something useful. Which is always great.
A while to upload. Let's scroll over.
I'll try again?
Yeah. Okay, an error.
Error occurred while...
Okay, let's double check to see if we've connected properly to the Arduino. Let's go to Tools and just make sure we have the right COM port. Okay, looks like it is. Looks like it's fine. So give it another...
This is not a Demilinov. This is an Uno.
Okay, that would answer that. Okay, let's try it again.
Same issue. Debounced Stream Deck. Error occurred. Done uploading.
Oh, okay. Let's try it out now. So let's go to our command.
And play this one?
Yeah, let's run this again.
Tools or run? Run main, right?
Yep. Okay, and let's try the...
Okay, and then we should also switch it over so we can show what we're testing right now. We're testing this way. And Chrome is just hidden for now. So right now it's reading here. Red button on, red button off. Blue button on, blue button off. So now we're keeping track of each button, and it's giving us useful serial inputs that's explaining what's happening with the program. That is friggin' sweet.
So it's telling us directly what's happening on the hardware side now.
Fantastic. So now we should try and figure out what we want to program each of these buttons to do.
Okay, and in this case, we want to actually... So one of the things that if you're using OBS Studio, it actually has the ability to recognize certain keystrokes and respond to them. So I guess what we do is we can show people how that looks like. We open up OBS Studio.
Yeah, let's do that.
Yeah,
so we're going to go into...
Twitch OBS Studio. That's fine.
This is fine. Sorry it's so ugly, guys. You're going to see it in Infinity for a moment. But we basically go over here to Settings. And then in the Settings here, we go to Hotkeys.
So what happens is that you can configure certain key combinations to trigger some events. So let's say that we want to do something here that's going to do something useful without actually hurting us in any way.
Yeah.
That you can see some action kind of going on. What looks useful here? Well, what looks useful?
Show webcam, show show desktop, show Arduino, show Dual Links, just chatting. Oh, I see. So you can actually have it change and turn on certain inputs and outputs. So let's have the first one here, I guess, to turn on and off the microphone. So that way we'll see here, while it's off, the mic should be off, and while the red light is on, the mic should be on. So that's a good enough one to start for now. I just have to see here.
I saw mic and auxiliary a moment ago.
Stream elements from mic. Where's mic? Oh, right here. So mic, auxiliary, mute, and unmute. So should we put in here a combination like Control M?
Let's see. Control M. Let's see. Yeah, I guess Control M.
Control M.
Right. So now if we apply this.
And Control M again for unmute.
Unmute.
Or Control Alt M maybe for unmute.
Actually, no. It looks like it does for telling. ABS tells it actually has to toggle, so it tells tell us.
Okay, so that's okay, right?
That should be fine, I believe. Yeah.
So should I? Oh, I guess it doesn't really need one, right? Control M.
Mm-hmm. So I believe that.
Or
that
just trash
fine.
it, maybe. There you go. That way you only need one, right? I think that the only reason why you would have specific one is so that you make sure that you do one action. But if it's a toggle, it's already a toggle, right?
I think you have to enter in twice in order to make his toggles. Because if you type in Control and then it tells us, you highlight over it, I believe. Yeah. Key combination shared to mute acts of toggle.
Okay, sweet.
Yeah, so click apply.
Okay. Okay.
Okay.
So now we're gonna go back to.
Let's just test it out, see if it works. Let's see if this key combo works. Press.
You guys didn't hear that because we were muted, but it worked.
Yeah. So yep. So it looks like this key combo works. Now, since we have a key combo mapped, now we actually have to make our Python program emit a Control M. How do we do that? Maybe we should go to Google.
Yeah, let's go to Google again.
Okay,
so let's open up Chrome here so you all can see what we're doing.
Okay, so
we go into Google's.
So we're going to type in Windows, Python,
keystrokes,
keystroke event. How to generate keystroke events. So on
Stack Overflow.
Stack Overflow.
Okay, let's pull this up a little bit so y'all can see. Let's make sure that it's doing that. Did it? Oh, I'm going to pull it up manually. So y'all can see what I'm reading right now. I'm trying to create a program that will send keyboard events to the computer for all the purpose of the simulated events to be treated as actual key source on the keyboard.
Hey, that's what we want.
I assume the function receives a key, so it must simulate pressing. So, keyboard event A, lowercase a, uppercase B, keyboard event right arrow key. Library module to simulate keyboard events.
So, of course, this is a question asked on Stack Overflow, which you should learn how to consult, because a lot of things happen on there that answers questions for you.
Yeah, there's a lot of really good stuff on here. Send keys?
Okay, but that's a Windows only event. We don't want that. Of course, this response is from 2012, which is a bit old.
That is old.
Something's happened in the meantime. Maybe we should check somewhere else. What do you think?
Yeah, I think so.
Let's go back to Google.
Python 3.
Wait a second. What is that on
keyboard? Pipey.
What does that do?
Pipey.
Hook and simulate events under Windows and Linux.
Pip install keyboard. So let's go into our virtual environment again, right?
Yep.
So let's stop this one.
Stop this. Go to the terminal.
Terminal. I'm still getting used to doing this, but it's pip install keyboard.
Let's scroll down. I believe so.
Let's just try
pip install keyboard. Let's do that.
Pip install. Oh, let's remove Chrome for a moment. Y'all can see what we're doing.
Pip install
keyboard.
So we're adding a library that hopefully will actually do keyboard event. Oh, installed.
That's it?
Yeah. Only 58K.
Okay, so now we should look in here and see what the heck it does, right?
How does it work? Okay. So it looks like it hooks into global hook. That means it emits keyboards as assuming that it's being typed on the keyboard. Oh, it looks like it supports complex hotkeys, control shift.
Oh, so that's exactly what we want. Literally what we want.
Literally what we want.
Oh my god, how do we use it?
How to use it? So they installed it.
Example. Import keyboard.
Then keyboard, press and release.
Shift S. Space. What, really?
Yes, that's it.
That's it?
That's it.
So we just want keyboard press and release. That's it?
Yeah.
So is this Shift S and then space? Or
well, that's two keys. So Shift S and then a space. It'll do them in sequence.
Really?
Yes, it can do a whole macro. It can actually type a whole.
Holy shoot!
Want a straight front?
Yeah, you could have your little macro for doing like bunny hopping or what is it? Like no scoping or whatever. So So we're going to import keyboard.
Okay. We're going to do a test, though, to make sure it works before we try and run. So we're going to
make a new one?
No, actually, we're going to do it in here.
Okay.
So
do we import keyboard still?
We're going to import keyboard.
Okay. Import keyboard.
We're going to make a new function, def test keyboard.
Def test
keyboard. Okay. And so let's actually look at the library, see how it works. Well, of course, all we have to do is just use keyboard dot press and release in order to do something. So we're going to do keyboard dot press and release. And then we have to tell it what to press and release. Okay, in this case, we defined our macro to be what?
Control M
plus M. So in quotation marks.
All right.
Control. So I think it's CTRL, not CNTRL.
Oh yeah, let's see.
Yeah, so let's actually go back to documentation. So the shift keys, I believe.
CTRL.
Yeah, CTRL.
So Control plus M.
Yeah, plus M. Okay, and then of course if we if we replace the main in the main function with test keyboard. Right here, we're going to change that around. I'll comment it out or just test keyboard. But we want to comment out the main because we don't want that to run. Okay, but the only downside is that this is going to immediately do it and then quit. We need a time delay. How should we do that? Does Python do time delays? Why, yes, I believe it does.
Yes, it does wait?
No, okay, so we have to import the library for that.
You have to import time.
Yeah, so we have to go up to the library, import time. And we want to put just ahead of this keyboard press and release, we want to put a time delay. So in the test keyboard code up here, not here, but we actually want up there.
Yeah.
And okay, we want to give a time delay, something like maybe 10 seconds. So delay, yes, that is.
Is it delay?
I believe it's wait or delay.
I thought it was wait. Although if we just do here, time.
Sleep.
Sleep. There you go.
How many seconds? Sleep maybe
10
seconds?
1 second?
10 seconds. So the moment we run it, we'll switch back to OBS and see if it mutes us.
Okay, here we go. So we're going to try and run it and see what happens.
Yep,
okay.
So we hit run.
Run main. And?
We'll see. 9, 8, 7, 6, 5,
It
4,
doesn't seem to have
3,
muted us.
2, 1, 0.
And they had no idea because it actually muted us, guys. It actually muted us.
Yes, our Python program just did a 10-second countdown. It muted it. We know we can emit any kind of keyboard event.
That's crazy.
Which means we can do it for any other kind of Windows program now too.
Yeah, that's freaking awesome.
You can automate stuff.
Oh, guys, we can do some crazy automation
with this. You can program your own macros.
That's sick.
For any program.
That is so sick. Make some sick freaking Counter-Strike macros, guys. Get banned.
Okay, so this is what you do in when you're kind of working on something that you don't know is going to work in the first round. You have to test. You have to create.
Test it.
You have to create something simple, dead simple that works because you don't want to confuse yourself about stuff. Now we know that we can read a keyboard, read this Arduino. Now we know we can emit events.
Yeah, we have to read it now. So we have serial.read line. So we should say. Was it line is equal to serial.read line?
Yeah.
So that way we inputting the serial.read line into a variable.
Yeah.
And then we're going to do something with that variable. We're going to say if.
We should split this because the text is
because it actually takes the.
Yeah.
So the first one's going to say like red button.
Or is it red button or button?
It'll be like red button, or blue button, or yellow button, and then on.
So the text it comes in 3 parts. So then how it works if you want to split text up, what you do is that in Python you use
line not split.
And a split on spaces. And then it's going to give us...
so we want to actually put it into itself. So we do line equals to line dot split, right?
We can do that, yeah.
Do we have to do that, or can we just declare it?
Okay, well actually it's going to create an array of 3 things. So I guess
we don't have to redeclare it, do we?
Yeah.
We just do line dot split.
Yeah, line. Actually, no, because then we lose it because we need to save it.
Oh right,
because it's 3 elements.
Okay.
So
line equals line dot split
or something. Yeah, and then of course we need.
Now we're going to get red, and then button, and then on.
Okay, so again.
So the first item, line 0.
Actually button. We need to create a new variable. Button.
So should we just let's print line for now.
Yeah, print line.
And show everybody what we're getting now.
Okay.
Yeah?
Yeah, we wanted to do that, yeah.
So let's save it.
For us.
Run it.
Oh, but we need to now...
stop it?
Stop it because, we have to re-establish the main program again. Right.
Oh, right, yeah.
Comment it out.
And we want to turn this off because this is going to mute us again.
Yeah, we're going to be muted maybe.
Actually, we'll just comment it out for now.
Comment.
Okay, run it. Okay, it's reading. It's reading.
Okay.
So press the button here.
Yep.
Red button on.
Mm-hmm.
So it's now red button off. Yellow button on. Yellow button off. So that's really great. It's actually split it up into different items. So that's what we expected. That's actually what we expected. So now we have an item, a list, and we have 3 different items in the list. And because Python lists things from like 0 to onwards.
0, 1, 2, 3. It indexes things by starting with 0.
So the first item is going to be item 0. That's going to be the color of the button. The second item in the list, button, is really kind of redundant. It's just for us
to read.
To read it. And the third item is going to be the status, which is actually on or off. So now we can actually take those things and read the properties of it.
Yeah, so we're going to split it up. So we're going to say...
So,
actually, you still want to print, because you still want to get some debugging feedback. You still want to leave that print.
Oh, right, yeah. Oh, yeah. So, but we can say LED, or color is equal to line 0. Line 0, right?
Line 0, yeah.
Item 0. And then we can say status
equals to...
or LED status equals to line 3. And these are all...
not 3, 2.
2, right. Yep. You're right.
Yeah.
So, but these are all local variables, so they're only paying attention to it while it's running in here.
So now, of course, you want to actually make a choice of what triggers. So which button you want to trigger the mute?
We want if red button, if color does equal to red. Then we want to go on to the next part. If LED status
equals
on,
and then we kind of emit.
Then we're going to use the keyboard press here.
Yeah.
Right? This one?
Yeah.
On. And then else.
Actually, we can actually change 2 statuses, right?
Oh, right.
But we need to reprogram a new macro. Like right now it's a toggle. So I guess in the future we actually want to...
We actually want to have them have separate ones.
Separate one.
So this one's going to be control equals to off.
Yep.
Then keyboard dot press and release.
Maybe control capital M. I think it's case sensitive. C plus capital M.
Okay, let's go into OBS and make sure we change that too.
Okay.
So go in here, file, settings, hotkeys. Scroll down. So this one's gonna be control plus control plus M.
I'll guess
this is control alt M. Yeah.
Okay, control M.
So control M will be the mute. Control alt M will be unmute.
All right.
Apply. Okay. Now let's go back to our program.
Yep.
Let's go back to the Python programming thing here.
Yeah.
Control
plus alt.
Control plus M. This is control plus alt plus M. Okay.
Okay, and now of course we need to actually include the keyboard. Actually, no, that should be fine. I realized because we
don't need this anymore.
Don't need this. Yeah, we already tested. Let's think. Any issues? Can you spawn any issues here that we might have? I think we're good. I think we're
ready
to
try
test.
it.
Okay.
I think we're ready to test.
Okay.
So let's run main.
Okay, and we're going to...
Let's index outer range.
Oh, let's see here.
Line 0.
Oh, that's because if it has a blank line, it's trying to split. It has nothing because remember it's reading continuously.
Oh.
Yes. So we need to wrap it. Maybe if lang.
If.
Oh yeah. If line equals not equals to. What do you think? Not equals to blank.
If line equals to. Then pass, right?
Yeah. No, actually, no. Pass. Or just skip that. If we want to actually continue, I think you can actually
continue.
Yeah, it goes back to the beginning of the curve, beginning of a function. Otherwise, it falls through and does all the other stuff. Does that make sense to you?
Yeah. So it should be else, and then this stuff in here.
Yeah.
Right.
Or actually, we just put it if it's not equal to this, then you do that stuff. That might be better.
Oh, yeah. If not line.
Or line not equal to. Or against the exclamation equal.
Oh, right.
Not equal to. I think that not equals or.
Let's try it.
We need to indent that stuff now. And also notice another thing. This is lowercase status, this is uppercase status. So we should match the variable names. We have the red underline telling us there's a... One nice thing about PyCharm, if you create a variable and you don't use it, it gives you yellow underlines that tell you, wait a second, you create this variable, you're never using it, which is nice. And yep, there you go. It's a syntax sounding really helpful in terms of helping debug. That's one nice thing about PyCharm.
Should we try it?
Let's see here. That should be, I think that's okay. I believe so.
This index out of range.
Okay, color. I think it's this. I think not equal because it can't do direct comparison because it's not the same thing as object. So I would say if length of line equals 0, because then it's a blank.
If length line
not equal to 0, because that means it's not an empty string, then actually testing is out. So I think maybe pass.
Or continue, right?
Yeah.
So let's try again.
Try that. It's working.
Okay, let's check and see if we're muted.
Muted.
We're not muted.
Okay.
It doesn't seem to be omitting those keystrokes.
Okay.
Okay.
We should put some debug code inside, see if actually it's hitting that or not.
Yeah, we should put that. So, we'll stop this for now.
Yeah.
So we also remember what that keyboard where it was just printing out the line. That was actually really useful. Yeah. We should have put that.
We should put it inside. So actually in here, actually we do this here. So we'll say print mute. And on the other one, we should do print unmute or mute to deactivate.
And we're just going to do muted and unmuted. And then else continue?
That should be fine. It should just skip over and just keep doing this stuff. We just want, whenever we hit it, to actually make you register.
Should try. Well,
yeah.
I don't know if it's even getting inside that block. Should we try again?
Oh, yeah, this is where we're going to test it. We just want to see what it does.
Run.
Okay, let's actually see. Okay, oh no, it's not hitting that somehow. So therefore the comparison is
if length line does not equals to 0. So it's printing the line here, but it's not going inside here because length line is never not equal to 0. But it's getting split first.
Okay, yeah, this is getting split properly. Oh, I see, because it's an array we split it into. So we actually want to do, trying to think here. We actually want to do splitting inside here.
Yeah, we do.
Yeah, you want to take that split and do it inside that.
Okay, let's try again. Run again.
Yeah.
Oops.
Oh, that's fine.
Okay.
Okay, let's run that. Okay, still not getting trigger.
Okay, so is this length equals length line? So length, what does length do?
That is the length of that string. So we're getting a string of line, we're printing it out. So let's just print the length of that as well too. Before that line, let's just print the length of that. See if our code's making sense. Len line.
Okay, stop this. Save it. Run it.
It is 0.
And then this one, 15.
Okay.
Yeah, it's reading the length.
Okay. Okay, but it's not going into your code. Maybe say greater than 0 instead of not equal to 0.
Okay, yeah.
So let's try that. Greater than 0. Let's try that again. Stop. Run. So this is called debugging. You're going to do this most of your time in your life.
Yeah, this is the real programming part.
Okay,
of it.
so it is number is bigger than that. So why isn't it actually? Oh, maybe it's because we're comparing these strings. I think maybe. Oh, I know why. You notice that says B. These are bytes, but these are strings with a Unicode. So one thing about Python 3's version now is strings are by default Unicode. So we're trying to compare bytes with Unicode, which is why it's not working.
So we need to create change. Is
so
it
we
string?
have to change these not to no. We have to change these to byte U in front.
Oh,
so these have to be into byte strings. So
like
U, yeah. So I believe, or maybe I'm sorry, B in front.
B.
So B, right? Yeah. So notice they changed. Now these are byte strings now because the output. Okay, this is a big gotcha.
What?
Okay, so I'm going to do an explanation right now. Okay, so right now, how many languages do you speak? Many languages in the world because we have an international audience.
Yeah.
But of course, back in in the old imperial times when the United States has homogeneity over the whole world, everyone had to speak English. No longer the case.
Yeah.
Black lives matter. Other lives matter. Foreigners matter. So we need to take into account with our software these days the fact that languages have to be able to express characters beyond the typical alphanumeric characters. So in previous version of Python, pre-Python 3, by assumption, the default brackets, quotes between anything was assumed to be just regular strings, ASCII. That means every single character was represented by one single byte. But with Python 3, the default string format is every single character is now a Unicode character, a 16-bit character expressed as many symbols there are in human languages. So whenever you just put quotation marks, what's assumed to be inside each character is actually a 16-bit value, a Unicode value. But however, the terminal we are using, again, this is ancient. This is RS-232. Every single character is assumed to be an 8-bit character. So we're trying to compare an 8-bit character with a 16-bit character. That R for red previously in quotation marks, that was a 16-bit character trying to compare to a red 8-bit character for R. It does not match, of course. So we need to make the comparison of our strings in old ASCII. So what it is that how I can actually define an old-fashioned string is what we do here. So instead of putting just a regular quotation mark, we put a B in front because of course it's very useful to specify byte-oriented characters, 8-bit characters. So B says the following stuff in the quotation mark is the old-fashioned 8-bit per character definition.
Okay.
So now
it kind of makes sense to me.
Yeah.
So wait, so this thing's outputting 8-bit or 16-bit?
Each character is an 8-bit character, 256 possible values. But of course, modern languages need more than that. So all characters. So
16-bit, right?
16-bit. So, but the thing is that whenever you create a string such as this com up over here, this COM6 : these are all Unicode characters, each is being represented by a 16-bit Unicode value. So that thing is not just 1, 2, 3, 4, 5 bytes, actually 10 bytes altogether.
Oh, wow. Okay.
Because each of those characters is represented by a 16-bit character. So, of course, it's not going to make sense when we compare stuff. It's going to give us the right comparisons.
Okay.
It's going to compare bitwise. So this is why instead of using a quotation red, we're using a B quotation red. So everything with B in front, this is a special kind of string. There's other kind of strings that exist as well, too, which is called regular expression string, and those codes have an R quotation mark something aside because that's how you create regular expressions.
Really?
Yeah, but of course, this whole saying, thinking you need regular expressions. If you have a problem and you need regular expressions to solve, and you use it, now you have two problems.
What?
Because now you have to handle regular expressions, which is a pain to debug.
I guess we'll cover that.
We'll cover that later,
another time.
But for now, it's a bit of a gotcha, very subtle. It's from the old ASCII to Unicode switchover.
That is definitely a gotcha because I would have no idea. Yeah. So basically, if we wanted to convert these into normal ones, we'd have to use some magic like coplate it with stir, right?
Yeah. So what is that? You have to. One way to do is to take the line or this color previous line and encode it into Unicode. And this way, you have to kind of say dot encode, which converts it to Unicode.
Okay.
But we're actually gonna.
This is easier to just use B.
Easier. It's just a little bit more easier.
So can we try this?
Let's try it now.
Okay. Run.
Okay, it's running. Let's see if the button works.
Okay, now if it works, you guys are gonna temporarily not be able to hear us, so we'll see what happens.
Mm-hmm.
Oh.
Okay.
It fired off muted, but it didn't unmute.
Okay. That's because we also have to do a Unicode comparison. That has to be converted.
I see another one.
Another gotcha.
So give me a second. I'm gonna.
Did it mute?
I apparently didn't mute.
Okay.
So let's add the B here off.
Yeah.
We'll stop it and let's play it again.
Yep.
I don't know why I didn't mute though.
Mm-hmm.
So let's try again.
Yep.
Run main. So now we're in main again. Check here. Right now we're still running. We're still got our thing.
Okay, we're gonna hit the button.
Hit the button here. Supposedly it muted us, but it didn't actually mute us.
Mm-hmm.
So we're in that block now though. We managed to get inside this block here.
It might be our the macros maybe in OBS. Let's double check it. Maybe we'll switch it instead of Control Alt M. Maybe a whole different character possibly, just to make it easier.
Settings.
It might just be do a toggle still perhaps.
Control M.
Maybe Control N to unmute. Or U.
Control U?
Yeah.
Okay, so Control U.
Yeah.
Apply. Okay.
Okay.
Well, it's not muting us in the first place either, though.
Let's try it here with the regular keyboard. Let's see if it does it. Control U to unmute. Okay, looks like it's working.
Control M and Control U are working on an actual keyboard, but not from this thing here.
Okay, so let's stop this code and rerun it. Just to make sure.
Stop again.
Yeah, we need to kind of change this to Control plus U to unmute.
Okay, and then we'll run it again.
Run again.
Okay, it's running.
Okay.
Press the button. Okay, it says we're muted right now. Let's go check. We're definitely still live. We're definitely, it didn't do what it said it did. Now press again. It says we unmuted. So it's doing that, but for some reason not doing the Control M and Control U. Keyboard press on release is not working.
So I wonder if maybe they might need to restart the program possibly because it may have grabbed something and not released it from the previous time. Maybe the keyboard events aren't going through correctly.
So what should we do?
Okay, I'm just trying to think how we can double check if that's the case. I suspect maybe that might be it. Because we had to kill the program in the middle, so maybe there's an instance of it kind of. Let's just check the task manager just to make sure.
Should we re-upload this?
No, this should be fine because this stuff's working.
The firmware's working.
The firmware working.
Okay, now what we do?
So I just actually can you open up the command line? I just want to see if there's maybe we have to reopen PyCharm possibly. I think that maybe there might be it grabbed a handle for the keyboard and maybe it didn't release it. Maybe the events aren't going through possibly.
Yeah. It managed to get into that function block, so it said muted and unmuted. So Python again. What should we do?
Okay, I'm just trying to think here.
Do we have to restart the stream?
No, I think maybe let's just restart PyCharm. I suspect maybe it. Let's close. Exit. Yep, we're going to restart PyCharm, see if that might be the case. I suspect maybe that might be the case. Because we had earlier tonight when we were running the PyCharm program, we had to kind of kill it by pressing Control-C, but sometimes that's bad in Windows because if you grab a resource and kill a program, it still grabs onto the resource. So I think a hook might not have been released.
Okay, how come it's not showing PyCharm anymore?
Oh, that's weird. Is it closed?
No, it's open.
Open.
That's weird. PyCharm. There we go.
Okay.
It was glitchy. And let's pull this down. Okay, so now we're back in our thing. We're here. We've got our terminal. We're good.
Actually, let's change this. So let's emit regular keyboard events. Maybe we'll have Notepad open and stuff just to see if it works. So we're gonna
just have it do M.
Just M.
M.
And just a U or something.
U.
Yeah. This way it'll emit regular keyboard events, and let's see if we can actually get something going to something like anything at all. So it's running.
So we're opening up Notepad now. Maybe we should open up the desktop so you can see that we're running Notepad.
Mm-hmm.
So I'm gonna press Notepad. Now we should get M's and U's in here.
Hey.
Whoa.
Moo.
Okay,
so it looks like this is actually working. That tells us we're emitting events.
This is so awesome. This makes me think that one of our projects we should create our own keyboard.
Yeah.
Like a keyboard out of these buttons. You see these little buttons here? We should totally 3D print our own little keyboard out of buttons. That would be freaking epic.
Okay, so we're debugging. So it looks like our code's working. It is actually emitting events. So might be OBS doing the issue then, possibly.
Yes.
Okay.
So now we're gonna go in here. We're going to our settings, and let's just make sure Control M Control U seems to unmute us.
Okay, so we're gonna actually modify our program.
So to do Control M and Control.
Yeah. Also, we actually want to say, should we actually add in? Let's actually have one of the keys actually quit this program.
Yeah.
Yeah, because now we know how to do. Now we know this stuff works. Maybe we'll have LED, the blue one, kind of kill the program or something.
Okay, sure.
Yeah, because it's gonna be hassle trying to scan the console as well too. We're gonna make it easier ourselves. So then, if color equals remember B quotation mark
blue.
And status equals B on. We're going to just actually just return. Just exit this whole function, and that should exit the program as well too.
Return.
Yeah, that makes sense.
Yeah.
Yeah. Okay.
Although I think that we'll never be able to. We'll just have to turn the blue off and then back on again.
Yeah.
Okay, that's probably fine, right? Should we run it?
Yeah.
Run. Oh, I see. It's run as well.
Oh, okay. Stop it. So it's running. So hit the red. It's emitting. Oh, okay. Oh, okay.
Control. Oh, it says CTRL. I didn't know CNTRL.
Oh, yeah. Okay, yeah.
Okay, run that again.
Yeah. Mm-hmm.
Let's go.
Mm-hmm.
Okay.
Yep.
Muted. Apparently we're muted. But it didn't do that into OBS.
Okay, so I think it's an OBS program. Let's actually make
OBS is not picking it up.
Yeah, so let's actually put a notepad again.
Okay.
Yeah.
Notepad.
Mm-hmm. Oh, because we changed back to Control M. That's what we did.
Oh, right, yeah.
I think that's what's getting rings. So, hey, I don't understand what you just typed.
But what if I have this program open? If I...
Okay, I think,
no, that's not
it's an OBS problem. Because it looks like Notepad's able to read it. So sorry, folks. We might have to restart OBS Studio or something like that. Or maybe we'll have to toggle. We'll have to play around with OBS.
Should we close it and open it again?
I'm trying to think. Actually, let's actually go back to what we had previously. Just maybe Control M only. Maybe it sounds like confusing it. Maybe what do you think?
Let's try it. Let's might as well try it. Let's just let's get rid of the settings.
Maybe we'll
go to hotkeys. We'll just try just Control M.
Let's actually delete them all first.
Or maybe we can just do M and U.
M and U.
M and U. Let's just do M and U.
Yeah, that's simpler. Apply.
So we're going here.
Code.
And this is just going to do M and U.
Mm-hmm.
Because it was reading in Notepad.
Yeah.
Okay, run it again.
Mm-hmm.
And open Notepad.
Yep.
It's not reading the M's for some reason.
Okay.
Why is it not reading the M's? That's weird.
Okay, let's go back to our code. So, press release.
What the heck?
Mm-hmm. Okay, so what broke here?
I don't know.
Okay, let's just we'll check here. Let's see here.
Oh, it should be LF color, right?
Oh yeah, LF.
Keyboard press and release M.
Mm-hmm.
Keyboard press and release U.
Mm-hmm.
Why was it not giving us the M? That's so weird. Should we just try again?
Try it again. Stop it. Rerun. Oh, it's actually coming up here.
Oh, whoa. Oh. But it's not giving us the M's again.
Okay.
Why is it not giving us the M's? It's so bizarre.
Okay, let's see here. Maybe it's not hitting the on event, but it should be. We're getting it here. Does it say muted?
Red button
it does
on.
Say muted. Yeah, it does say muted. What is going on here?
That's weird.
Mm-hmm.
What the heck?
Let's see here. What is going on? So we have to quit PyCharm and restart it because again, we had to control quit this in the middle of it.
Yeah, we did.
I think it glitches at that point when we ever do that.
Yeah.
Yeah. So
close again. Reopen it.
Yeah. Close up. Close on PyCharm. Reopen it. Yes.
You.
Mm-hmm. You.
Should we run again?
Let's run this. Mm-hmm.
Okay. Terminal Python console. Nope.
No, we just have to go to run top.
Run main.
Mm-hmm. It's running.
Okay, it's running.
getting used there.
That's so weird. We're not getting the other stuff though. The M's are gone now.
Oh, for some reason. What's happening here?
That is bizarre.
Okay. We're figuring it out here.
Is it doing it in here? Oh, it is switching our scenes though. What the fuck?
Oh, because we're hitting the U's. Therefore, because we're highlighting, it's trying to find another U in this list.
Okay.
Yeah. Because it's trying to go probably just chatting because it's trying to match any of the characters that we're typing in. Yeah, I guess that's why people use the control characters, because then it doesn't affect anything in the real actual interface.
Okay, so yeah, I guess we'll try and use control again.
Yeah.
Control M, Control NU. Apply. Okay. Now let's go back to our Python program here.
I don't think people are seeing anything. Let's go back to our OBS.
Oh yeah, you're right. Why did PyCharm die again?
That's because we close and reopen it.
There we go. Now we're back. So now press this. Oh, let's exit it.
Oh, we have to restart it.
Speaking of Bizarro, Bizarro just jumped on. Baron Von Murder Pillow.
Okay, it's hitting the code here. Let's just double check if it is.
It should be control plus.
Yeah. Oh, it's a CTRL.
Oh, sorry.
Not CNTL. Yeah. And summary.
Maybe I should do lowercase u? I don't know.
Maybe. Yeah. Let's try lowercase m.
We'll stop that and run it again.
Yep. Okay, so it's happening here. Let's actually go to our maybe OBS Studio, see if it's picking it up now or not. Okay.
So it is toggling. But it's not toggling in the way that we want it to. Because oh, I see. No, it is toggling the way we want it to right now. Because right now we're live.
Yep.
Which means the red button's on, which means it shows that we're live.
Yep.
And then when I press it's working.
It's working. So it looks like it needs to be lowercase m, lowercase letters.
Yeah.
Okay, now we know, again, this is debugging.
That was weird.
Uh-huh.
Basically, it needed lowercase letters in order to work. That's so fun. That's weird.
This is what you do.
But now we've got our little stream deck here. We can press our button here.
Can we quit it?
And again.
Okay, what happened a moment ago? We muted everybody.
Yeah, now you guys, we muted everything.
Our toggling's working now. It's switching back between the two different states now. So, okay, now we learned some lessons. The keyboard library works. The gotcha, though, is that when you define what keystrokes you're going to use, the actual letters have to be lowercase in order for it to read properly.
What?
Is the way it is.
That's bizarre. I don't understand why. Now we can go in here. We can add more hotkeys. So let's go in here. Let's go and choose our webcam stuff.
Switch scenes.
So, oh yeah. Oh, should we have it switch scenes?
Or something.
I was thinking maybe turn the webcam on and off, but
okay, yeah, let's do that. So I guess
webcam. There's no turn on or off.
Maybe it might. If you go higher, it might be just Windows. Just turn off window. Oh, show hide windows.
Windows.
That's within a.
I think that's actually one of these scenes.
Yeah. So again, what we do is that we go to the.
So yeah, it's actually one of these scenes.
But actually, we're currently in the Python programming. We have that enabled, so we have to go back to your definitions of your macros.
Okay.
Right. So right now we're on the Twitch Python programming scene. So we're now going to enable on the speaker scene in the hotkeys and the list of elements that you see here.
Oh, look at this! We can actually switch the scene with the specific one.
Yeah, you do that too. Or you can hide webcam and show webcam as well within a particular scene.
Right.
But this is only for particular. Again, it's customized per scene.
Yeah.
So if we want to go into, but if you want to do for all, I believe here, does it do it all?
Start virtual camera, stop virtual camera.
No. I believe you have to customize it on a scene by scene basis. So we go to the Twitch Python programming scene. There should be entry for that.
Here we go. This one here.
We can actually do it. key combo.
So what should we do? Let's do Control W.
Yep.
And we'll just have it a toggle.
Yeah, can toggle. Although we don't know.
Oh, right. We don't want it to do that.
Or Control Alt.
Oh, Control Alt W.
Yeah.
Oh, we can probably do that with the other one too now.
Yeah.
This one, Control Alt M.
Apply.
Okay, so
now we have to go to our Python code and map it. So we're going to do
so this one's going to be Control plus M. This one's going to be Control
plus
Alt plus M.
And now we're going to handle the green LED.
Or a blue LED, right?
Oh, I guess we don't want the LED to exit, so we want the green to exit now.
Yeah, well, maybe we should hook up another button.
Yeah.
We should
or actually,
now that we've got this all working out, we should probably put more buttons on it now. Because right now we've only got 3 buttons, and they're all toggle buttons.
Yeah.
Really, we want more buttons because we want, like, I don't know, like, probably a bunch of different buttons for different scenes, right?
Yeah.
So you can go, like, scene 1, scene 2, scene 3. Let me think here. Really, you want that to be a big line of them, don't you? Because it's like 1 to 8 or whatever.
Yeah, but that's easy enough to extend because we easily kind of create the code for that now. But the key is that we don't need to do that right now. The key is that we're trying to figure out just a general idea of what the programming environment is. Then first, just make it work.
Yeah, that's a good idea. That's a good idea. So let's just do blue now.
Yeah.
So now blue is going to.
If it's on, I guess that's going to webcam on.
I mean, do we really need to turn the webcam on and off?
Well, this is just to practice.
Well, yeah, that's right.
The whole idea. This is a practice thing. So
now we want to do keyboard dot press and release. And this is going to be Control plus
W, lowercase w.
W.
And then else.
LF.
LED. Underscore slash equals D off. So.
Control plus Alt plus W.
And I guess we also put some kind of print statements as well too, which we did previously.
Right.
Yep. So in this case, for this one, we want to print cam off. Or is that cam on? No, it's cam on.
Cam on. Print cam off. Sweet.
And do you want to
we'll do yellow. Let's do something with the yellow one.
Yeah.
What should we do with the yellow?
So for the moment, we're actually just using exit programs. Otherwise, you have to kind of control quit this, but sometimes it breaks it.
Right. Yeah. So yeah, we should have this one just do it.
For now, it's just going to kill this entire Python program. For now.
So just would it be pass or
just return.
Return.
And this will exit, and it'll kill it'll turn the stream up. But this is just a temporary thing because it just makes it easy to debug. Later on, I'm going to make we're going to actually create an actual Windows GUI later on that we control the stuff and also define the buttons because you don't want to define code every single time.
Yeah, that's a pain.
The novice. Oh, to remap your buttons, open up your Python IDE. Screw that.
Yeah. I'm not. This sounds like a real pain in my butt.
I thought this was supposed to be an easy project.
This is supposed to be easy.
Eventually, we're going to create a GUI, some kind of dialog box. You hit settings, and then it'll have a box that's checkbox. Do you want control? Do you want alt? What key?
Like a little setup wizard.
Setup wizard and stuff.
Setup wizard, maybe a TK enter or something.
Yeah, some of that. So, but at current moment, we're just going to do primitive.
So let's see
to
here.
Make sure it works.
The first thing here. No, we should be muted.
Okay, let's actually go.
Oh no, we're not muted.
Okay.
Because we were now live.
Yeah.
So now if I press the button now. Oh, did it get updated?
Okay. Did it save and update? Is it running? Stop it.
Give me a second. Maybe I should close the program and reopen it again. Because it doesn't seem to be picking up this Control Alt M.
Is it mapped properly? Just made the alt.
Let's just go check in the settings here.
Yeah,
make sure the settings here, the hotkeys are set up properly. So that's Control W, Control Alt W, Control M, Control Alt M.
Okay, let's double check the keyboard library. So maybe some subtleties. Actually, go back to here to keyboard, which is.
Well, let's make sure we turn on Chrome again.
Yeah.
And we'll move Chrome down here.
So let's switch over that. Let's go back to keyboard on top there. Okay, let's see. We can do the Alt keys. I believe we should be able to. Limitations. Let's see here. Press ID. Okay, let's go to the documentation. So they can have Control and Shift. Is it Alt? Let's see. I don't know. I notice they also have it's all in lowercase. But let's double check the documentation. Let's go to the API docs. Okay, so we want to have keyboard.
Press and release, right?
Yep, press and release. And so yeah, we already have that. And oh, they also have send, alias. Oh yeah, it's Control plus Alt plus whatever keys you can actually.
Oh, so it's actually supposed to be all lowercase. So let's try it again.
Let's try it again.
So that might be messing with it.
Unless we're going to interfering with Windows predefined keys as well too, because we want to be careful that it's not.
All good?
Yeah, that's good.
Okay, run it again.
Let's run it again.
Okay, so first things first. That should be on. Although we shouldn't be muted, right? Are we muted? We're not muted right now.
No.
Right now it's backwards. Is it?
To on is mute.
Right, it needs to be the backwards
yeah.
situation. So this one.
Yeah, because that's on light. Right.
Right.
So you should flip it around.
So this one should be down here. And this one should be up there.
And let's make sure it makes sense. Yeah, webcam. I think that makes sense.
It should be live.
Yeah.
Or mic unmuted. Or mic live. And then mic muted. Okay. So let me stop that.
Stop that.
Play again. Okay, and then we're going to check our thing here. And let's close Chrome so y'all can see what we're doing. Press that button. Okay, mic live. There we go. So it's on. Press again. On again. Now we're live. So now the light's on when we're live. That's properly. Now let's see if this kills the webcam. Cam on. Oh, there we go. Disappeared. And now we're back again.
Working.
Dude, the Stream Deck is doing some crazy stuff now. Now we're actually getting it working. See, I can turn the cam on and off with the button now. I can also mute us. No, that's really neat.
The function works.
And we even have little LEDs on here to tell us
what the status is.
What the status is.
We don't have to look at our screen. We have to look down our Stream Deck.
That is freaking sweet. You guys don't know, but I like here. Let me show you guys.
I'll hold it up.
Oh shoot!
Oops. Okay, get this cable.
There you go. But okay, so the first button here is our red LED, and when we press the red LED, it mutes us. It mutes us. The second one, the blue LED, when it turns off, we disappear. We disappear. And I turn it back on, and dude, that's crazy. That's awesome.
You can't see it. The moment you press that button, the blue LED went off, and the webcam went off.
Exactly that.
And the second time, this went on. You saw the camera on.
That's so cool. That's neat.
We actually have an actually working Stream Deck.
We have a working Stream Deck, guys. Yay!
So we
did it.
We have.
Yeah.
It's all kind of spaghetti code, hacky.
It's very, very hacky. But it's working.
It's working.
It's working.
We have our proof of principle in action.
That's awesome. Whew. Okay, so what do we do now?
Okay. Well, okay, so should we delve into TK Interview with people?
Should we? I don't know.
Okay.
At this moment, I'm thinking
bask in the glory.
Just bask in the glory for a moment.
Don't confuse people too much.
We did it, though.
Yeah, we did it.
We did it.
Well, there it is, folks. We proved it this week. Now, next week is going to be optimization, polish, making a product that you can use, and not just us.
Yeah, and we're also going to hopefully be able to put those files up on Thingiverse. So if you guys want to 3D print your own Stream Deck, you can take our files and make your own.
And eventually
it's all going to be open source.
And we're going to put this on GitHub as well too. Therefore, you can download the code and play around and install as well too for your own purposes.
It should be pretty easy. You just got to load it up onto your Arduino, wire it up in the same way. I guess we'll have to also put a wiring diagram.
Yeah.
And then also
provide the code as well too. Next week we're going to the code is we're not going to put up code right away. We want to have it a little more polished. So next week we're going to go on to the next level, which is creating a GUI interface, because you want to be able to have some kind of dialog box that says for this thing that the red button you can actually maybe put a little checkbox. Do you want Control? Do you want Alt? And then which key you want to actually have a little drop down or something like that, or maybe some select of some kind. So we can actually have it create whatever keys you actually want it to actually toggle whenever the red button's on, red button's off, or whatever. You customize it, and then you can customize OBS Studio whatever you want it to be.
Because right now it works, but it's not the super most usable thing yet. Because again, you don't really want to have this all those wires and let me just bring it close so you can see here. So it's really you don't want that's not very usable, right? So now now that we've got it working and we have it working bare bones as a breadboard, and then also working at bare bones as a software. We're going to try and make the whole thing a little bit nicer as a whole package, so that hopefully you guys can use it and enjoy it. Yeah.
Yeah, so that was tonight's broadcast. A little bit less long compared to last week.
Yeah, because last week we did a 5-hour stream. That was intense, guys. And that's just because we were hacking at it. We were getting into we got into a groove last time. But thank you guys so much for watching. I hope you guys enjoyed that, and I will see you guys next time.
See you next week. Same bad time, same bad channel.
Yes, and if you guys are watching this on YouTube, please like and subscribe. It really helps out the channel, and that's how you can show you guys' love and appreciation. If you guys like the stream, please check me out on Twitch as well. All right? Thank you guys so much, and I'll see you next time. Bye.
Bye.
Bye, everyone.